Hello everyone, so in this video I'm going to discuss Jan 22 Shift 1 memory based questions in physics. Right, so around 20 questions I'm going to discuss in this video, and the difficulty is again on the it is like moderate, and in this paper if you're scoring like above 70 it is a very good score. Now let us see the very first question. A parallel plate capacitor of capacitance 40 microfarad is connected to 100 volt power supply. Now the intermediate space between the plate is filled with a dielectric material of dielectric constant 2. Due to the introduction of dielectric, the extra charge and the change in the electrostatic energy in the capacitor respectively. So when we connect a parallel plate capacitor with a battery of EMF 100 volts, so this is 100 volts, capacitance is 40 microfarad. Then the charge on the capacitor plates will be CV, so that will be 40 times 100, so that will be 4000 microcoulomb. So the charge will be 4 millicoulomb, right? On this plate will be minus 4 millicoulomb. So this will be positive plate, this will be negative plate. Now what we are going to, we are inserting a dielectric slab between the plates. Now when we insert dielectric slab, keeping this battery intact, we are not removing the battery, the capacitance will change. So the new capacitance will be C prime, which will be 2 times, because the dielectric constant is 2 times C, so that comes out to be 80 microfarad. So the new charge will be C prime times V, so that will be 80 times 100 microcoulomb, so that is nothing but 8 millicoulomb. So the charge is increasing on the plate from 4 millicoulomb to 8 millicoulomb. So the increase in charge will be 8 minus 4, so that will be 4 millicoulomb. So if you look at the options, so option C is the right answer. So a uniform circular disc of radius r and mass m is rotating about an axis perpendicular to its plane and passing through its center. A small circular part of radius r by 2 is removed from the original disc as shown in the figure. Find moment of inertia of the remaining part of the original disc about the axis as given above. So here we have to find the moment of inertia about this axis. So I'm assuming we have to find the moment of inertia about this axis. So here m is the mass of the complete disk. So what we can do in this case, the moment of inertia about this particular axis will be moment of inertia of the big disk about that axis minus moment of inertia of the small disk about that axis. So in order to find the moment of inertia of the big disk, it is nothing but m r square by 2, because it is passing through the center of mass of that big disk. And for small disk, we have to apply parallel axis theorem. So first we'll find the moment of inertia about the axis passing through the center of mass of the small disk. So we can say moment of inertia of the small disk about the given axis will be I about center of mass plus mass of the small disk times r by 2 square, because the distance between these two axes is r by 2. So what is IC? So IC in this case will be, so first let us find the mass of the small disk. So we can say mass of small disk will be m divided by pi r square, that is mass per unit area, times the area of the small disk, pi r square by 4, so that comes out to be m by 4. So it will be m by 4 times r by 2 square divided by 2. So that is the formula of moment of inertia about the axis passing through the center of the disk. So this comes out to be m r square divided by 32. So it will be m r square divided by 32 plus this is m by 4 r square by 4. So it comes out to be 5 mr square by 32. So we have to just take the difference. So 1 by 2 minus 5 by 32 mr square. So that comes out to be so 32. So this will be 16 minus 5. So 13 by 32. So option D is the right answer. Right. So let us say this question: an electron in the ground state of the hydrogen atom has the orbit radius of 5.3 into 10 raised to power minus 11 meter. while that of the electron in the third excited state. So third excited state means n equals to 4 is 8.48 angstrom. The ratio of the de Broglie's wavelength of electron in the ground state to that in the excited state, right? So we know that de Broglie's wavelength is inversely proportional to the velocity, and velocity is inversely proportional to the principal quantum number, right? N. So we can say lambda is directly proportional to n. So lambda 1 divided by lambda 4 will be 1 by 4, right? So I think they want us to find lambda 4 by 1, lambda 4 by lambda 1, so that will be 4. So in that case, the answer will be C. So find the dimensions of B by mu naught, a very basic question from units and dimension. So first of all, think about a formula which for any formula of magnetic field. So let us consider the formula of magnetic field produced by the current carrying circular coil at its center. So that will be mu naught I by 2R. So mu naught I by 2R divided by mu naught. So that will be B by mu naught, right? So the dimension, so mu naught will get cancelled out. So it will be having dimension same as I by R, which is nothing but ampere length raised to power -1. So option B is the right answer. Right, so let us say this question given below are two statements. One is labeled as statement 1 and the other is labeled as statement 2. Statement 1, in a vernier caliper, one vernier scale division is smaller than one main scale division. Right, so in vernier caliper, least count is defined as 1 main scale division minus 1 vernier scale division. So statement 1 is correct. So for standard vernier caliper, we have this thing, right? So 1 main scale division is always greater than 1 vernier scale division. Now statement 2, the vernier constant is given by 1 main scale division multiplied by the number of vernier scale division. So that is incorrect because vernier constant is nothing but least count, and it is given given by 1 main scale division it is not multiplication, it is the subtraction of the two divisions. So statement 2 is incorrect. So if you look at the option D is the right answer. Statement 1 is true, but the statement 2 is false. Okay, a bob of mass m. So this question is from vertical circle. A bob of mass m is suspended at a point O by a light string of length L and left to perform vertical motion. Initially, by applying horizontal velocity V0 at the point A, the string becomes slack when the bob reaches at the point D. So at point D, the tension becomes 0. So which is a case of in this particular case, the velocity at the bottommost point will be root of 5gl, right? So and we have to find the ratio of kinetic energy of the bob at the point B and C. So kinetic energy at B and kinetic energy at C. So what we can do, we can find the kinetic energy at B by using energy conservation between A and B. So from A to B, kinetic energy at A minus kinetic energy at B will be equals to the gain in gravitational potential energy, which will be mg h1, where h1 is L minus L cos theta. So that will be mg L1 minus cos 60 degree. So from and what is the kinetic energy at B? So from this, kinetic energy at A will be half m 5gl minus mgl times 1 minus cos 60 will be 1 by 2. So this comes out to be 5 minus 1 by 2 mgl, which comes out to be 2 mgl. So we got the kinetic energy at B. Now let us apply energy conservation between B and C. So from B to C, kinetic energy at C minus, at B minus kinetic energy at C will be gain in gravitational potential energy. So this height h2 will be 2 L cos 60 degree, where cos 60 is 1 by 2, so that is nothing but L. So it will be mgl. So kinetic energy at C will be kinetic energy at B minus mgl, and kinetic energy at B is 2 mgl. So minus mgl, so that comes out to be mgl, right? So we have to find the ratio. So kinetic energy at B is 2 mgl, whereas at C it is mgl, so it comes out to be 2:1. So option A is the right answer. Right, so let us see this question, which is from calorimetry. Ice at minus 10 degrees Celsius is to be converted into steam at 110 degrees Celsius. Mass of ice is 10 raised per minus 3 kilograms. What amount of heat is required? So here we have ice 10 raised to power minus 3 kilogram of ice, right? So we can say we have 1 gram of ice. So we can directly consider it as 1 gram of ice. So 1 gram ice at minus 10 degrees Celsius. Now first we'll increase the temperature of this ice. So we'll get 1 gram of ice at 0 degrees Celsius. Then there will be a phase change. So we'll get 1 gram of water at 0 degrees Celsius. Then we'll increase the temperature of water. So 1 gram of water at 100 degrees Celsius. Then there will be a phase change of water. So 1 gram of steam at 100 degrees Celsius. Then we'll increase the temperature of the stream. So it will be 1 gram of steam at 110 degrees Celsius. So here this so I'm assuming the specific heat capacity of ice is 0.5 grams per degree Celsius per gram. So from let me call this as Q1, this heat as Q2, Q3, Q4 and Q5, right? So Q1 will be MS, which is 0.5, and the increase in temperature is 10, so that will be 5 calorie. Q2 is the latent heat of fusion, which is 80 calories per gram. So we have 1 gram of ice, so times 80, so it will be 80 calorie. Now Q3, we have water. We want to increase the temperature of water by 100 degrees Celsius. So mass of water times the specific heat capacity of water will be 1 calorie per gram per degree Celsius multiplied with 100. So that will be 100 calorie. Then we have Q4, which is the latent heat of vaporization. Here to vaporize 1 gram of water, we require 540 calories. So it will be 1 into 540. So that comes out to be 540 calorie. Then Q5, we have to increase the temperature of steam. So here I'm assuming the specific heat capacity of steam as 0.5 calories per gram per degree Celsius. So that will be 1 into 0.5 times 10. So that will be 5 calorie. So let us add up all these. So if we add all these, so we have 540, 640, 720, 730 is the answer, right? Option A is the right answer. Right, so the next question is from ray optics and it is based on, okay, so lens formula. So given is a thin convex lens of glass, refractive index is mu, and each slope have the radius of curvature r. One side is polished for complete reflection. At what distance from the lens an object be placed and the optical axis so that the image sets form on the object itself. So we have given a biconvex lens and one side is silvered, right? So basically we have a combination of a lens and a converging mirror. So in this case, the power of this lens or this combination will be 2 times the power of lens plus 1 times the power of mirror, because it is passing through the medium 2 times. So we have to take the 2 factor here, right? So this will be so we can write this as 2, and in case of a converging lens the power is positive, so that will be 2 by focal length of lens plus, and for a converging mirror the power is positive, so that will be 1 by focal length of mirror, right? So focal length, so 1 by FL will be mu minus 1 times 2 by r, right? So from this we can say it will be 4 by r mu minus 1 plus, and for mirror focal length is half of the radius of curvature, so that will be 2 by R. Now from this, we can take 2 by R as common. So we'll get 2 mu minus 2 plus 1. So that will be 2 mu minus 1 times 2 by R. So we got effective power of the combination, which comes out to be positive. So the effective combination is behaving like a converging mirror. So if we have a converging mirror, and if you want to form the object at the object is want to form the image at the object itself, the object has to be placed at the center of curvature, right? So we got so 1 by f of the effective, and we have to find the distance. So this distance is nothing but 2 times f effective. So let us take this 2 on this side. So 2 times f effective will be r by 2 mu minus 1. So option C is the right answer. Right, so let us see this question. An electron is made to enter symmetrically between two parallel and equally opposite charged metal plates, each of 10 centimeter long. The electron emerges out of the electric field region with a horizontal component of 10 raised to 6 meters per second. If the magnitude of the electric field between the plate is 9.1 volt per centimeter, then the vertical component of the velocity of the electron is, so mass of the electron is given and the charge on the electron is given, right? So we have given two plates. Let us say this is positive charge, positively charged plate, and this is negatively charged plate, and there is an electron which is entering symmetrically and it is having certain velocity, right? Let us say this velocity is Vx, and since this electron will experience force only in the vertical direction, the horizontal component of velocity will not change, and we have given horizontal component as 10 raised to 6. So this is nothing but 10 raised to 6 meters per second. So due to the electric field which is in the downward direction, it will experience force in the upward direction and it will deviate and comes out. So at this particular point it will be having Vx component which will not change, and it will be having Vy component, and we have to find the magnitude, vertical component, we have to find Vy. So the acceleration in the y direction will be E times capital E by m. So we can say V, and the time taken by the electron to cover this length of 10 centimeter. So time will be distance, which will be 0.1 meter divided by the speed in the x direction, which is 10 raised to 6. So we can say 10 raised to minus 7 seconds. So we got the time. So now we can apply kinematics equation. So velocity in the y direction will be uy plus ayt. So where initial velocity in the y direction is 0, acceleration will be E capital E by m times time t, right? So that should be the Vy component in the y direction. So E is 1.6 into 10 raised to minus 19, and electric field is given as 9.1 volt per centimeter, which is 10 raised to minus 2 in the denominator. Time is 10 raised to minus 7, and mass is given as 9.1 into 10 raised to minus 31. So 9.1 will get cancelled out. So we are getting 1.6 into 10 raised to minus 19 plus 2 minus 7 plus 31. So this comes out to be minus 17 minus 24 and 7. So 1.6 into 10 raised to 7, so which is 16 into 10 raised to 6 meters per second. So option B is the right answer. So the next question is based on photoelectric effect. The work function of cesium and lithium metal are 1.9 electron volt and 2.5 electron volt. If we incident a light of wavelengths 550 nanometer on these two metals, then photoelectric effect is possible for the case of. So basically we have to check whether the incident light or the is greater than work function or not, right? If the energy of the incident light is greater than work function, then it will be able to carry out photoelectric emission, otherwise not. So let us find the energy of incident photon in electron volt. So that will be 12400 or 1240 divided by 550, right? So if we simplify this, so this comes out to be, so 124 divided by 50, so it will be 2.25 electron volt, right? So the incident photon um, energy is greater than 1.9, but it is less than 2.5. So it will not able to carry out photoelectric emission in lithium, but it will be able to carry out photoelectric emission in cesium. So cesium only, right? So it will be able to carry out emission in cesium. Right, so let us see the next question. A closed organ pipe and an open organ pipe are filled by two different gases having same bulk modulus but different densities, rho 1 and rho 2 respectively. The frequency of ninth harmonic of closed tube is identical with the fourth harmonic of the open tube. So we have given a closed tube and there is an open tube. Right, if the length of the closed tube is 10 centimeter, so this length is given as 10 centimeter and that is this length is L. So we have to, and we have given the ratio of densities of the medium rho 1 and by rho 2 is 1 by 16. Then the length of the open organ pipe, so L we have to calculate, and it is resonating in the ninth harmonic, and the and the open tube is resonating in the fourth harmonic, and their frequencies are equal, right? So we know that in case of a closed organ pipe, the resonating frequency is given as 2n minus 1 V by 4 L. So these are the resonating frequencies, right? So it is ninth harmonic. So so the fundamental frequency is V by 4L. So ninth harmonic will be 9V by 4L. And fourth harmonic, so in case of a open organ pipe, fundamental frequency is V by 2L. So it will be 4V by 2L, right? In case of a open organ pipe. So we can say 9V, let me call it as V1, right? By 4 times 10 centimeter is equals to 4V2 by 2 times L. So let us simplify this. So this will give us 2, and we know that velocity of sound is given as square root of B by rho, right? B by rho 1 and V2 will be B by rho 2. So from this V1 by V2 will be root of rho 2 by rho 1. So we can find L as 2 times 4 times 0.1. I'm converting this into meters, divided by 9. Then V2 by V1, which will be root of rho 1 by rho 2. And rho 1 by rho 2 is given as 1 by 16. So that will be 2 into 4 times 0.1 by 9 times root of 1 by 16. So root of 1 by 16 is 1 by 4. So this will get cancelled out. So we're getting 2 by 9 times 0.1. So if I multiply this with 100 to convert this into centimeters, so we will get 20 by 9 centimeters. 20 by 9. So option D is the right answer. Now let us see this question. A small point of mass m is placed at the distance 2r from the center of a big uniform solid sphere of mass m of radius r. The gravitational force on the mass m, so there is a mass m here, right? Due to m, right? So both have same mass, right? So the gravitational force on mass m due to mass m is F1. A spherical part of radius r by 3 is removed from the big sphere as shown in the figure, and the gravitational force on m due to the remaining part of the mass is found to be F2. So we have to find the ratio of the forces F1 and F2. Okay, right. So F1 is quite easy to calculate, which is nothing but so F1 is G m square divided by square of the distance between the center of the sphere and the mass, so which is 2r, square of that. So this comes out to be G m square upon 4 r square. Now in case of a cavity, what we can do, we can we can find the suppose if we have a small sphere of radius r by 3 placed at this particular distance, right, from the mass. So what is the force due to this small sphere? So for that we need to find the mass of this. So mass of small sphere will be m divided by 4 by 3 pi r cube times volume of the small sphere, that is 4 by 3 pi r by 3 cube. So this 4 by 3 will get cancelled out and r cube will also get cancelled out. So we are getting m by 27. So the mass of this small sphere is m by 27. So the contribution of force to due to this mass, let me call this as f prime. So this f prime will be g small m by 27 divided by the distance between them. So this will be r plus r by 3. So which is r plus r by 3, that will be 4r by 3. So 4r by 3 square. So this is 9 and this will become 3. So g m square divided by 3 times 16r square. So we got f prime. And so we can say f2 in this case will be f1 minus f prime, right? Because that mass has been removed. So its contribution towards the force will also get subtracted. So f1 minus f prime, so that will be 1 by 4 minus 1 by 48 g m square by r square. So this will be, let us multiply it with 12. So we're getting 11 by 48 g m square by r square. And we have to find the ratio of f1 and f2. So f1 by f2 will be 1 by 4 divided by 11 by 48. So that will be 1 by 4 times 48 by 11. So that will be 12 ratio 11. So option B is the right answer. Right, so let us see this question. Two spherical black bodies of radii 0.2 centimeter and 0.4 centimeter are at temperature 400 Kelvin, 800 Kelvin. If the energy radiated by the small body is E, then the energy radiated by the larger body. So this question is based on Stephens-Boltzmann law, where the rate at which the energy is being radiated will be E a sigma T raised to power 4. And we have to find, okay, right. So we have to just take the ratio, right? So we have given E, that will be black body. So in case of black body, E will be 1. So that will be A1 sigma T1 raised to power 4. And let us say for the other body it is E prime. So it will be A2 sigma T2 raised to power 4. So E prime by E will be A2 by A1 T2 by T1 raised to power 4. So let us substitute the value. So the surface area of the second body or the bigger body is 4 pi 0.4 into 10 raised to power minus 2 square divided by 4 pi 0.2 into 10 raised to power minus 2 square. And the temperature is also given. For the bigger body it is 800 and for the smaller it is 400 raised to power 4. So this will cancel out, this will give us 2. So this will cancel out. So we have 4 times 2 raised to power 4. So 4 times 2 raised to power 4 is 16. So it should be 64. So E prime is 64 times E. So option C is the right answer. Let's see the next question. Given below are two statements, one is labeled as assertion and the other is labeled as reason. If the Young's double slit experiment is performed in a optically denser medium than air, then the consecutive fringe comes closer. So we know fringe width is given as d lambda by small d. So if we increase the refractive index of the medium, then wavelength will decrease. So wavelength will become lambda by mu. So wavelength will decrease. So beta will also decrease. So the consecutive fringes will come closer. So assertion is correct. Now the reason is the speed of light reduces in an optical denser medium than air while its frequency doesn't change. So reason, it is the correct justification, because as the speed decreases we can say lambda will also decrease. So it will be both A and R are true. So B is the right answer. Now let us see this question. Find current in a circuit. Jockey is at the middle point on 1 ohm. So okay, right. So we have 1 ohm and we have to find the find current in the circuit. So we have to find the current supplied by the battery. So we can, what we can do, so it is in the middle. So we can say to the left we have 0.5 ohms, to the right we have 0.5 ohms. Let me draw the equivalent circuit. So we have a battery of 0.9 volt. Here we have 0.5 ohms. Here we have 0.5 ohms. And this will be 2 ohms, right? Now this 0.5 and 2, let us find the R equivalent. 2 and 0.5 are in parallel. So it will be 2 times 0.5 divided by 2.5. So this will give us 2 by 5, right? Or 0.4. So this will be 0.4. 0.4 and 0.5 are in series, so becomes 0.9. So R equivalent is 0.9. So the current will be 1 ampere. So 1 ampere is the answer. Now the next question is find the radius of curvature of a common surface of two bubbles. So let me draw the diagram. So we have given R1 is greater than R2. So there is a bubble of radius R1 and there is another bubble of radius R2. And we have to find the radius of curvature of this common surface. Again, very basic question, right? So this bubble has a radius R1, this bubble has a radius R2, and let's say this bubble, this surface has a radius R. So we have to find R. So we know that the excess pressure in case of a bubble is 4s by R, where R is the radius of curvature, S is the surface tension. So we can say at point A, pressure at point A is greater than pressure at point B by 4s by R. Now pressure at A is greater than, let us say outside we have atmospheric pressure. So pressure at A is greater than atmospheric pressure by 4s by R2 minus P naught, and pressure at B will be greater than atmospheric pressure by 4s by R1. So from this P naught will get cancelled out, 4s will also get cancelled out, so we'll get 1 by R2 minus 1 by R1 equals to 1 by R. So R comes out to be R1 R2 upon R1 minus R2. So that should be the answer. So the next question is based on finding the equivalent capacitance. So here we have given parallel plate where this area is A by 2 and this area is A by 2. So where we have two dielectric K1 and K2 in series, and this combination is in parallel with another dielectric K3, right? So we can say this combination is just like two capacitors in series, and this combination is in parallel with this capacitor. So this is K1, this is K2, and this is K3. So let me call this as C1, C2, and this is C3. So what is C1? So C1 can be written as epsilon naught times the dielectric constant times the area divided by the width between the plates. So let us say this is d by 2, right? So which comes out to be epsilon naught K1 A by D. Similarly, C2 will be epsilon naught times K2 times A by D. And C3 will be epsilon naught times K3 times A by 2 divided by D. So that will be epsilon naught K3 A divided by 2D. Now C1 and C2 are in series. So we can say the combination. So we can say this combination, we can, this will be 1 by C equivalent will be 1 by C1 plus 1 by C2. So which will be D by epsilon naught A times 1 by K1 plus 1 by K2. Or we can say this is nothing but epsilon naught A K1 K2 divided by D K1 plus K2. Now this capacitor is in parallel with C3. So the answer will be C3 plus this, let me call it C equivalent prime, right? So C3 plus C equivalent prime, so that will be epsilon naught K3 A by 2D plus epsilon naught A K1 K2 by K1 plus K2 times D. So let us take epsilon naught A by D as common. So this comes out to be K3 by 2 plus K1 K2 upon K1 plus K2. So this will become K1 K3 plus K3 K2 plus 2 K1 K2 divided by 2 times K1 plus K2 times epsilon naught A by T. So let us see the option. Um, so we have 2 K1 K2 K1 plus K2 in the denominator. So see, first option is incorrect. So K1 2 times K1 K2 2 times K1 K2. So option 2 is the right answer. Now let us another question. So in this question we have to find in which circuit we have diode in the forward biased mode. So we know that in the forward biased mode, the P side, so we have a diode, so this will be the P side and this will be the N side. So the P side will be at the high potential. So in this case we have 0 volt, here we have minus 15. So we can say in this case it is in forward biased mode. Here it is in reverse biased because this is 2 and this is 4. Here it is again reverse biased, and here we have 0 and here we have minus 3, again reverse biased. So option 1 is the right answer. Now let us see another question. So radius of the electron in the ground state for hydrogen atom is A naught. The radius of the electron in helium positive ion is in third excited state. So we know that the radius in the nth orbit is A naught times n square by z, and z will be 1. So it will be A naught n square, right? In case of a hydrogen. So n is for the first orbit, n will be 1 for helium, and there will be z in the denominator in case of a isoelectronic species. Here we have given helium positive. So for helium, for the fourth orbit, third excited state means the fourth orbit, so it will be A naught times 4 square divided by, for helium z is 2, so this will become 16, 8 A naught. So this is given as A. So A naught by A will be 1 by 8. So that should be the answer. Now this question is based on how the resistivity varies with temperature in case of conductor. So we know that resistivity increases as we increase the temperature non-linearly. So option 1 is the right answer. And this question, here we have to find the effective power where this combination is given. So this is R1 and this is R2. So here we have 3 thin lenses connected in series. So effective power will be P1 plus P2 plus P3. And we have 2 converging lenses and 1 diverging lens. So let me call this lens 1, this is 2 and this is 3. For lens 1, 1 by F1 will be 4 by 3 minus 1, I am applying lens maker's formula, times 1 by R1. So which is 4 minus 3, so that will be 1 by 3 R1. So we can say P1 is 1 by 3 R1. And for the third lens, so 1 by F3 will be 4 by 3 minus 1 times 1 by R2, which is 1 by 3 R2. So P3 will be 1 by 3 R2. And for the middle one, 1 by F2 will be 3 by 2 minus 1, and it will be 1 by minus R1 minus of R2. So this comes out to be 1 by 2 with a negative sign. So it will be R1 plus R2 divided by R1 R2. And in case of a diverging lens, the power is negative. So it will be minus of R1 plus R2 divided by 2 times R1 R2. So let us simplify this. So 6 R1 R2 will be the denominator. So it will be 3 times R2 minus 3 R1 minus 3 R2 plus 2 times R1. So this comes out to be, so 3 R2 will get cancelled out, and we are getting minus R1 divided by, let me again check. So it will be 3 R1, 3 R2, and we have, sorry, it should be 2, right? It's not 3, it should be 2. It should be 2 R2. So it won't get cancelled out. So we are getting R2, so that will be minus R1 minus R2 divided by 6 times R1 R2. So that comes out to be minus of 1 by 6 times R1 plus R2 divided by R1 R2. So that should be the effective power. Since effective power comes out to be negative, this combination will behave like a diverging lens. Right, so if you look at the questions which I have discussed in this video, so those questions, like I would say, whatever question I have discussed, 2 to 3 questions were challenging, rest of the questions were easily doable. So in this paper, if you are scoring above 70 marks, you will very easily get above 99 percentile in physics. Right, so see you in the next video.